In this diagram, you see that there are two masses, 3 kg and 6 kg, which are attached with the same spring, massless spring, and the spring is compressed. So right now, the total momentum of the system is zero, but the energy is not zero, and it stores 1.0 joule of energy in this system. So when you will uncompress the spring, or when you will release, if you have holded the two blocks, when you will release them, so both blocks will move in opposite direction. So this will be the speed of y, and this will be the speed of x. So in this question we have to find out the speed of y when you will release the spring. So let's divide this question in the two situations. The one we see that before releasing the spring. So students, this is a moment just after you release the spring. It doesn't mean that the spring is fully released, or because the spring will gain once again 1 joule of energy if no energy is lost. So it is just moment after you release the spring, and this is the velocity of y, and this is a velocity, this is a speed of x. So in this question, although we want to find out the speed of vy, okay, the so block y, but what are unknowns? We don't know the speed of x, we don't know the speed of y. All right, so that's why we need two equations. Okay, because whatever principle you will apply, you will eventually get the two unknowns. To solve these two unknowns, we need two equations. Now we know one thing, that there is a no external force applied in this system before releasing and after releasing. That's why we can apply law of conservation of momentum. What is a total initial momentum? So dear students, that is 0 kilogram meter per second, because both are at rest. But what is the momentum of the both springs, or both blocks? So we can say it is mx vx, all right, and this is my vy. So when you will apply law of conservation of momentum, so if there is a no external force exerted on a system, so it means that the total change in momentum of system is zero, which means that the total initial momentum is equals to the total final momentum. So if I put the values, 0 is equals to mx, which is 3, and vx plus 6 vy. So we got an equation. Now this can be equation 1, but let's go first on the other principle, because we know that it has stored 1 joule of energy. Now how the conservation of energy is followed, or how the energy is conserved in this example? So it is the elastic potential energy. You are well familiar about this elastic potential energy, this energy that is stored in the spring, which is in our curriculum. It is written like 1 over 2 k delta x square. This is a elastic potential energy. So right now this is stored in the spring, and this energy will convert into the kinetic energy of both masses. So we can say total energy of system before an event or before release of spring is equals to the total energy after release. And when we look at the question, because the both masses were at rest, so there's a no energy, and in fact there's a no kinetic energy of the both blocks, but 1 joule is the elastic potential energy, which will convert into, which will divide into the kinetic energies of both masses. So 1 over 2 into mx vx square is the kinetic energy of the mass x, plus 1 over 2 my vy square. So it is the moment when the spring has not stretched, okay, because then there will be a third, we should put a third term, that is a elastic potential energy once again, because the spring will stretch. So that's why I'm repeating again that this is the moment, these are the two energies existing at the moment when you have just released the spring. So if we put the values, so 1 is equals to 1 over 2 into 3 vx square. You can multiply on both sides with 2, so we can get 2 is equals to 3 vx square plus 6 vy square. Okay, and moreover, now this is our equation 2, And I was talking about equation 1, don't forget here. Right now what we can do, we can get a one variable in in a form of another variable. So what will be appropriate? I mean, if you take 6vy term on the other side, so it will be negative 6vy is equals to 3vx. So vx, the speed of the velocity of x, is equals to negative of 2vy. So you can put this value in the equation 2. So let's put the value 2 is equals to 3 into, let's put the value vx, because in that case we can eliminate vx. So it is negative 2vy whole square plus 6vy square. So if we solve it algebraic equation, now we have just one unknown in this equation, and this will be 4vy square plus 6vy square. So 2 is equals to 12vy square plus 6vy square. 2 is equals to 18 vy square. We want to find vy, so that is 2 over 18, and then you can take square root. So when you will take square root, we will get, by the way, 1 over, when you will take square root of 1 over 9, you can get plus minus 1 over 3 meter per second. And what we have already seen, that the velocity will be a positive value because it's directed towards the right side. So we should consider only 1 over 3 meter per second, that is 0.33 meter per second. So that's why the right answer must be option B. And I hope you understand this lengthy procedure of, because it was basically more mathematical.